Hello everyone, myself Sarika Yadav. Today I will introduce rectifiers and filters. In basic electronics, rectifiers and filters are important elements. These rectifiers and filters are mostly used in DC power supply. With the help of rectifiers and filters, we can convert AC supply into DC. We have already seen the diodes and its basic working principle. Now we will see the actual applications of diode in our rectifiers part. The rectifiers are classified into two types, that is half-wave rectifier and full-wave rectifier. First of all, we will understand what is the meaning of half-wave rectifier. This is the circuit diagram of half-wave rectifier. In this, we have used only one diode. The AC supply is applied at the primary terminal of transformer and diode is connected with the secondary winding of the transformer. Now, during positive half cycle, upper terminal is positive and this down terminal is negative, due to which positive supply is connected to the anode of the diode and negative supply is connected to the cathode terminal of the diode, due to which diode is forward bias. Forward bias diode acts as a closed switch, due to which current will easily flow through this diode, and hence during positive half cycle we are getting the output voltage same as input. Now during negative half cycle, upper terminal is negative and this down terminal is positive, due to which negative supply is going to the anode and positive supply is going to the cathode. Hence diode is reverse bias. Now reverse bias diode acts as an open switch, due to which current will not flow through the load resistor. Hence we are getting zero output at the negative half cycle of the input. As this rectifier works only for one half cycle, hence it is called as half wave rectifier. If I will reverse or opposite, I will change the direction of this diode. This will work only for negative half cycle. Now we will see the full wave rectifier. In full wave rectifier, first type is center tap rectifier. The name given center tap just because we have used center tap transformer in this rectifier. AC input is applied at the primary winding of rectifier and diodes are connected at the secondary windings of rectifier transformer. Here we have used two diodes D1 and D2. During positive half cycle, terminal A is positive and B is negative, due to which diode D1 is forward bias and D2 is reverse bias. So current will flow through the load R due to diode D1, as forward bias diode acts as a closed switch. Hence during positive half cycle we are getting the output just because of diode D1. During negative half cycle, diode terminal A is negative and B is positive, due to which positive supply is connected to anode of diode D2. Hence D2 is forward bias and D1 is reversed bias. So during negative half cycle, I will get the positive output just because of diode D2 is conducting. Hence this rectifier works for both positive and negative half cycle. This is called as full wave rectifier. Here we will see the actual direction of current in which it is flowing when diode D1 is on and when diode D2 is on. Orange color line indicates the direction of current coming from diode D1 and green color line indicates the direction of current coming from D2. But if we will look at the load terminal, both the currents are flowing in same direction through my load, and hence at the output we are getting DC supply. Now, one more kind of full wave rectifier called as bridge rectifier. Here we have used 4 diodes in a bridge fashion. During positive half cycle, diode, the upper terminal is positive, so supply coming at terminal E is positive and supply coming at terminal F is negative. Now, due to which out of these 4 diodes, only 2 diodes will be conducting. Here you will see the proper diagram. We have considered positive half cycle. For that, diode D1 and D2 are conducting, just because we are getting positive supply at the anode of D2. Similarly, negative supply at the cathode of diode D2. For diode D3 and D4, as they are reversed bias, current will not flow through them. Hence, during positive half cycle, we are getting the output because of diode D1 and D2 are conducting. Now, during negative half cycle, the upper terminal is negative and this down terminal is positive, due to which this negative terminal is connected to cathode of diode D3. That means D3 will be forward bias. Similarly, this positive terminal is connected to anode part of diode D4, due to which D4 is forward bias. Hence, during negative half cycle, diode D3 and D4 are conducting, and hence we are getting the output at load resistor due to diode D3 and D4. During negative half cycle, diode D1 and D2 are reversed bias, due to which current will not flow through them. As in bridge rectifier also, we are getting the output at load during positive and negative half cycle both. Hence, this rectifier is called as full wave rectifier. In this way, we have covered 3 different types of rectifiers. Now, as we have got the output at rectifier end, still it is not pure DC. It is called as pulsated DC at the end of the rectifier. To make it pure DC, we need to purify it in a more proper way, and for that we used filters. So I will give you the introduction part of filters in next video. Before that, just try to listen to this video one more time and draw the diagram of half wave rectifier, full wave, center tap, as well as bridge rectifier diagrams with their proper input-output waveform. That will be the kind of assignment and that will make your understanding more clear. This is actual waveform that we are getting with full wave rectifier. If my input waveform is AC signal like this, then I will get the output at the rectifier for each half cycle like this, and this is called as pulsating DC output. Thank you for watching this video and try to follow the instructions and assignment.